Hello, my name is Ture Nielsen and I'm a field application engineer at Dialog Semiconductor. Today I'm going to introduce to you our latest Bluetooth Low Energy innovation, the DA14585 Development Kit Basic. This development kit gives you the flexibility to develop your product with confidence, creating more advanced connected applications with the smallest footprint and power budgets. At the core of this development kit is our SmartBond DA14585. It is the smallest, lowest power and most integrated Bluetooth system-on-chip solution currently available. And this versatile system-on-chip brings Bluetooth 5.0 functionality to our well-known DA14585X family. In addition to it offers great flexibility with features like extended user RAM of 96 KB, wide operating voltage range from 0.9 volts to 3.6, I2S and PDM audio interface for voice support, and Bluetooth Low Energy mesh. In fact, our DA14585 is ideal for adding Bluetooth Low Energy to products like remote controls, proximity tag, beacons, connected medical devices, smart home nodes, and much more. In this video, I'll show you how to set up this development kit and explain some of its important features. I'll tell you more about the Dialog tools you need, and I'll give you a couple of quick demonstrations. How to connect the hardware and the programming environment with the help of an LED BLINKY project. And a simple BLE example with the help of the Barebone project, in which we'll see the peripheral advertising itself. Let's first take a look at what you get with the Development Kit Basic. A single basic board containing the DA14585, a mini USB cable, and a coin cell battery. Let's take a closer look at some of the most important features and functionalities of the basic board. A USB UART SWD interface, GPIO connections, SPI flash memory, the mounted DA14585 device, and the PCB antenna. Okay, so let's start by setting up your development environment. In addition to the Dialog DA14585 Development Kit Basic, you will need a computer, a mobile phone or tablet with Bluetooth Low Energy Scanner app. I suggest using Light Blue for iOS or BLE Scanner for Android. First, you'll need to download some software from the Dialog Customer Support website. Here you will find the latest version of the software development kit and the Smart Snippet Studio, which is a launcher platform where you will find all you need for your application development. The software installation process is shown in the Development Kit Getting Started guide, which can also be found under the Development Kit documentation. After successful installation of the Smart Snippet Studio, you can now launch the Kyle IDE for ARMCC compilation and the Smart Snippets toolbox for the firmware download. Right, so that should be us all set up. Now we'll show you the step-by-step procedure to run the BLINKY project. We use this simple project to test run the functionality of the whole environment. The first step is to connect your DA14585 Development Kit Basic to your PC. This should be done using the micro USB cable. Also check jumper J9 to connect the LED. Now open the BLINKY project, which is in the peripheral example folder, like this. You can see the full path name on the screen. We then need to build the project by either using the Build button or by simply pressing F7. You can now download the executable to your Development Kit Pro. Press the Debug button or Ctrl F5. And then press Run or F5. If you have followed the step correctly, you will see the green LED blinking like this. Okay, so now we're up and running. I can show you the Barebone example. Here we see a DA14585 connected peripheral advertising via a scanner application like a smartphone or tablet. To start, we keep the same hardware, connected as we described in the BLINKY example before. Open the Barebone project, which is in the BLE-examples folder. You can see the full path on the screen right now. From the Kyle project window, expand the user config folder and open the user config header file. Search for user device name and change the string to dialog test. Now open the DA14585 config advanced header file and search for the CFG NVDS tag BD address. Here we need to change the default 6 bytes Bluetooth device address like shown on the screen here. Now we can build the project by either using the build button or by simply pressing F7. Once again, we download the executable to the Development Kit Pro, press the debug button or Ctrl F5. Then you can press Run or F5. Now we need to open the BLE scanner application on the smartphone or the tablet. For this demonstration, we're using light blue. If you have followed the steps correctly, you will see your peripheral device appear in the peripheral nearby list. It will be advertising itself with the name Dialog Test. This was an overview of the DA14585 Development Kit Basic with our latest Bluetooth 5 system-on-chip innovation. I hope you really enjoyed this video and found it very useful. For more advanced system development, there's also a pro version of this development kit, which has the DA14585 on a separate daughter board, allowing additional functionality to be tested. If you have any further questions, head over to our customer support website. You can check the forums, download the latest product documentation, and send us your feedback. I'm sure you'll find the answers you need to develop your product with our DA14585 Development Kit Basic.